Doesn't make sense. All right, so we're back. Stop the recording. Setting the auto record, so I should be recording. Yeah. Any questions so far? What I said, I've said a lot. So please do understand what I just said. Do we understand what I said? Hello, my people. Are you there? Do you understand what I said? Because if you don't understand, yes. You understand the example I've given to explain the combination of data sets. It's a combination of what data sets. Data set one is a linear lines, something like lines. Yeah, the data set two is sort of polygons, and we just want to overlay and see which areas are of interest. Do you understand the union overlay? This one is a union.
Hello, sir.
Overlay. This is the intersect. Yes, I'm listening to you. Go ahead.
I want to ask the data information of 1 and 2.
Say that again.
Always, and I'm talking about the first sketch. I want to show something on the first sketch.
The first one, what has it done? What's your question on it?
Please go back to the first sketch, the sketch that you did, the first one. This is the first data on the linear, the straight, the linear one, and then the polygon. I'm talking about the 1 and 2.
Yes.
Is it always in a case that maybe on a project, you realize that this area that you made a polygon will be affected or will not be affected? Is it always replaced like a polygon, or you can use any other way of replacing, maybe triangle, or maybe that one also can be depending on the size of the area? You can use the same linear way of marking the same area also.
Okay, so these diagrams that I've done, thank you very much. I got to it. So these diagrams are only generic. So what it means is that in real life, they may not even look like that at all. So you can have a very funny shape, okay? And then you have to, determine that, okay, this road, this is a road section. Is that okay? I want to find out what is happening around this area. Okay, so you were talking about, instead of using, say, something looking more like a square-ish, rectangular, can we use something that is extremely irregular? Yes. In fact, it can be as complex as possible. Are you okay? You can even have, there's a type of, spatial units. When I say spatial units, what I really mean is polygon or something like that. Like anything looking like a polygon. That has a hole in the middle of it. So that will be very interesting when you have something like this. Then the middle, there is nothing there. Okay, so it's like some kind of, bottomless pit. Nothing happens in the center. So there exists a feature like that. Are you okay? But please, I don't want to take it to that level. All I want you to understand now is that we can have layers. stack up like this. So you can have one layer, can have another layer, can have another one, okay, can have another. And then on each layer, you can have something, you know, on it that is interesting. Maybe a linear feature, a polygonal feature. Okay, are you okay? On the last one, you can have, I don't know, a set of points. Are you okay? And then now you decide that I want to add, if I can have a satellite imagery as part of the layers. So maybe the layer at the bottom is a satellite image. So this one, this layer here. So how many layers we have? We have 1, 2, 3, 4, 5. Are you okay? And then they are all they are for a particular place. That's the thing about layers. If they are not for the same geographical extent, you can't talk about layers. You can't go and pick. So I can ask you a very funny question, just to test if you follow what I'm even talking about. Where I'll tell you that you have data for cars, right? You have data at wager. Can you overlay them? Simple question in the exam that you know, if it's like you think, oh, this lecturer is too wicked to ask this question. You understand what I'm saying? But your answer should be that it's not possible because they are two different places. So the whole idea of layers is that it's for the same coordinates. It has to be over the same set of coordinates. Are we okay? All right. So good question, but I think it will force me to take it a bit higher than I need to. So yeah, whether we can try it on rectangles, yes, it's possible. You can do more complex operations. All right. Any more? Please do follow. The reason we are being taught, I'm giving you a lecture is because there are questions waiting for you very soon. So please always have that in mind. Otherwise, we wouldn't be having a lecture. I always like to tell students why we are doing what we are doing. So please try and get an understanding, yeah? Seek wisdom in order get understanding. It's the right place to get it. Okay, so if no question, I'd like to move on, please. Someone was saying something. If the person wants to ask a question, please go ahead and ask.
Yeah, I was about to ask a question, but let's move on later.
Okay, that's fine. All right, so we can do this combination. All right, can do this combination and beautiful. Do the whole analysis, get some results. That's it. Okay. I think that's all. Let's move on. Let's talk about the next topic. Okay, this diagram here. This is another diagram that's important. It's similar to what I was talking about. So if you look at this diagram, you can see that we can have a combination. So on the right hand side, we have, you know, this one. We are adding this and that. We are getting this one. All right. So here too, we are explaining the symmetric difference. It's like as if this is being cut out. Cookie cutter, are you okay? So one of the applications is that someone gives you a huge data set. You said you wanted wager, right? And I said, come and take the whole of Accra. Now you don't know what to do with it. Now you are using the whole data set. Your computer is even getting through. Why don't you cut it? So you see, you can use something like the intersect. Normally the intersect overlay does a beautiful job. And then the intersection area is what you're interested in. Okay, so it's up to the person who is using the GIS and how they want to apply it. Okay.
Hello, sir.
Yes.
Sir, please. So, I'm getting confused, Mom.
Don't get confused.
I want some these layers. Okay. So these layers. Is it only applicable maybe for if maybe you are going to, like the project that you are talking about, that you are going to embark? How are you going to determine the layers? Like how are you going to determine the layers when you get, oh, the layers, is it about data that we are getting?
Okay. I think so this is Gotthold.
Yeah.
The answer to this question is in the next topic, which is data acquisition. So I'm yet to get there. So it means you are far ahead of the class, which is very good. You are really thinking. That's good. We use different methods to get the data, and then we can do this operation. So without the data acquisition, you can't do this. So that should answer your question. So let's move on, as you said. So when we do the data, we will have to go there and map it. So this is what, if I normally surveyors do a lot of that data acquisition. So that is why surveyors work with civil engineers. Okay, survey engineers work with civil engineers and etc. And then we can get it. Okay, so that's it. That's it. I think that answers your question. Unless you're not clear about it, that can. Do you understand what I said? Do you understand my answer? Got to.
Yes, sir. Yes, sir.
Yes, your answer is in the next.
So, but I know, I understand the data aspect, but what I want to know is the layers itself. I'm trying to picture like
exactly what it is.
If I get to, yeah, what is it that layer is that I can see or lay my hands and say, okay, this thing is layers related to the G.
Okay. Have you used AutoCAD? You are in level 400. Have you used AutoCAD before as a civil engineer?
Yeah.
You know AutoCAD actually that's what I'm talking about. In fact, is what AutoCAD is doing that I'm talking about. I hope you're aware. If you've actually used AutoCAD before, you realize that I'm talking about something that is done in AutoCAD. Or you probably don't know your CAD very well. Because if you do,
I know
you realize that the concept of layers in AutoCAD,
the GIS aspect.
No, it's the same thing. What we do in AutoCAD, where we switch on the layers and we switch them off, is the same thing that happens in GIS. So GIS, remember one of the components is the software, and it's the software that we get the data into, and then the software runs on the hardware, and the people use the software. Understand why we can talk about some of these things. This happens in the software. Are you okay? Yes. So yeah, I hope I've been able to answer your question to some extent. Are you good? Are you sure?
Yes, let's continue.
Okay, great. Thanks for your question. The questions really help. So please, those who are not asking questions, I'm not going to like you. Is that okay? If you are here and you are not asking questions, remember that I am not going to like you a lot. Okay, so now on your screen, you can see I have two layers for the same place. Are we good? Are we good? You will do some practicals, so don't rush. Try and get the concepts. Sometimes university is like that. Everything, some things are just conceptual. Try to understand the concept. Please, are you getting what I got? Are you seeing the example on the screen? Yeah.
Yeah, we can see it.
Yeah, I'm seeing it. I'm seeing it.
Good. Okay, let's move on.
I'm seeing it.
Let's move on. Okay, so the next topic is buffering. Okay. All right, but of course I have this one here, data extraction and all that. So I think I've already talked about it, that you can actually extract data from a larger data sets. Okay. And so you can do that via map overlaying. Okay, but so now let's move on into buffer operation. So what is a buffer operation? So before I talk about buffer operations, we all know what happened in Cote d'Ivoire, where the North was fighting the South. Unfortunately, Africans, we're always fighting. Are you all right? I don't know, we enjoy fighting. So now they send in the UN, and when the UN gets in there, they go into the middle, are you okay, between the North and the South. And what do they call that? They call that a buffer zone. Okay, so the military know about this. If there's a soldier here, he knows about it, that I'm not lying, that there's a place, okay, what that you can actually create, a zone that you can actually create. Okay, it's similar to that. So when we talk about buffers, start thinking about things like that. But what really is a buffer operation? Buffering is used to constrain the space around individual features. So think about the features that we were mentioning. and think about how you're going to constrain space around it. So this is quite mathematical. Is that okay? So let's go to the whiteboard. There's this thing that keeps on popping on my screen. All right, so Microsoft Whiteboard. How many hours are we supposed to do? Please, I think I didn't check on the timetable. Can someone help me? How many hours are we supposed to do?
It's supposed to be 3 hours.
Oh, okay. So let's go a bit further today so that we can cover some ground.
That you do 2 hours, so no problem.
Oh no. I'll do 3 hours today. Today maybe I'll only do 4 hours. Let's go on. So buffering, let me show you. So you have a feature that looks like this. What is this? Maybe it's a trench. Are you okay? Maybe this is a trench. The black line I've drawn, it represents it, a trench. If I want to buffer, I constrain. It's English language. I constrain the space around it. What does it mean, constrain? That means keep a certain distance. Yes. Are you okay? Yes. Keep a certain distance. How do I keep a certain distance from it? It's mathematical. When we did maths back in school, GHS or whatever else, secondary school, our math teacher might have taught us this, but this is where the application comes in. When you constrain space around an object, are you okay? Coordinate geometry and those things. I think you still remember. I can decide to keep a distance of so much, this distance to the right and to the left. I'm not really drawing it by the same amount. So let me try it again. Where the distance from here to here and the distance from here to here are the same. So I'm constraining space. What if I come to the top of it and I decide to also constrain that same distance? And I cap it like that. And I come below it, and then I also keep some spacing. And then I draw a semicircle. Are you okay? Whose center is actually this point. So you realize that I have created a certain buffer zone. Okay, what it means is that anybody who is this distance, let's call it M or L or whatever you want to call it, we can decide that, okay, this is a project which is actually it carries a certain risk that nobody's supposed to be there to get that close to the project. So we need to keep this distance so that nobody crosses it. So to build a fence around it, this is the area. This is the part, the red line defines the boundary. That is buffering and how it happens in real life. Obviously, everything that I say like this and describe like this is done on a computer, but the data has to be collected through a data acquisition method. Okay, I think I've taken my time to speak on this one. Yes, Benjamin, go for it. I didn't finish talking about it, but Benjamin has a question. Okay, so Benjamin, yes.
Let me, if I get you right, let me.
Right. Okay, go ahead.
Let's say we are digging a foundation for a building, okay, and you need working space. So meaning that you have to, if you are going to dig a column of, let's say, 200 square mm, you have to dig 400 square mm so that you cut a working space. So that working space will serve as your buffer. Is it something like the buffer that you are talking about?
Yes, brilliant, Benjamin. That is exactly what it is. And it happens a lot of times when you are doing projects and you need to keep some space around. Let's take the example of fire belts. So a farm project, and we don't want the farm to get gutted by fire. So every farmer in Ghana knows that there's something called fire belts. That means that they weed around their farms. The question to the class now is that, let me just go straight for this one. This is the farm boundary. Next to your farm, to the north, to the east, to the right, other people have their farms, isn't it? Great. Now, a polygon buffer can be done within, in which we have equal distances away from the original polygon, or we can do it without, where the the buffer region is defined outside. Are you okay? And so we have this. The two are not the same. All right. This one is called the outer buffer. And this one is called the inner buffer.
Yeah.
Which one of them would you go for if you were to recommend? Engineers are like problem solvers. I mean, seriously, I don't know what engineers do than to give some wisdom. Where
Yes, it says.
what it should be. Would you go for inner buffer or outer buffer in the scenario given?
The inner one.
Okay, you explain, because you just can't. It could be a lottery. You are trying a lottery. So
okay,
give an explanation.
So in relation to the fire belt, let's say if I go for the inner one, it will prevent the fire from spreading out from my farm.
Why not the outer? Why not the outer?
If I create the outer one, definitely is going to my farm will be maintained, but it will go to the other ones.
No, you'll be working on
Hello,
people.
sir. Let me
come in.
Hello, sir.
Please raise your hand before you talk, so that we know. After, who is talking now?
Michael.
So next time, raise your hand. Then.
Okay, sir. Yes, sir. Sir, I think the outer buffer will be more relevant, mostly with regards to especially gas pipeline and oil pipelines. Like we're talking about the buffer zones that are created on each side.
No, hold it. Who is speaking now?
Michael.
Michael, remember that once you say pipeline, pipelines are linear features. What we are talking about is polygonal features. So the two don't marry. It's like talking about African something, you are bringing Japan. Are you okay? It's like zero. It's not. So don't mix the two. It's okay. Deal with something that is polygonal. Are you okay?
Yes, sir.
Okay, so let the next person go ahead. Got to.
When you talk about the fire aspect, you realize that the land, your boundaries, you have to use the inner rather than them, because when you use inner, you are doing it according to your land. But
That's
when
right.
you go outside, you take another person's land.
That's right. And that brings a whole lot of issues to deal with. I mean, seriously, you have to write letters to go and ask them for permission. I want to cut something on your land and all that. Why didn't you do it within your own boundary? So I think that is the answer I'm looking for.
Hello, sir.
Yes.
Can it also be that if we are looking at the buffer as a restricted area,
right,
sort of, then it will be appropriate to go for the inner one, because then now you have the outer one to work with than going in for the outer one as the buffer, if I'm clear.
Okay, so don't bring the word outer if you are going for the inner. Don't just say that you go for the inner because you want to be working within your project boundary.
Exactly, because that the inner one will be the restricted.
Yes, but you can imagine that there's been a lot of conflict and problems, especially in the countryside, where people are, illiteracy rates are very high in Africa. And people may never understand concepts like this, and they will fight, and all because of things like, can you imagine that? So then they have to send in a surveyor there to go and do some survey. Some simple things like this have created war between families. People have been killed and shot for no reason than things like this. Are you okay? All right, so let's move on. I think it always sounds interesting. All right. So there are three types of buffers. We have point buffer, . line buffer, then we have polygon buffer. The point buffer will give you, what would the point buffer give you? What zone would it give you? What would the shape of the zone? Let me see who gets this right. Line buffer, we've seen it. Yes, line buffer will look like this. We've seen an example. And we also seen an example on polygon buffer up there. Is that okay? Now who can tell us what the point buffer will give us?
A circle.
Circle.
Beautiful. I think you guys you've passed this course. Make sure everyone should get 80 plus. I know anybody who gets 50.
Okay.
No, I mean seriously, I'm impressed.
Sir, can I say something?
Yes, go ahead.
Point buffer.
So if we are saying buffer in relation to the point buffer, if
Yeah.
let's say we relate it to our GIS system like Google Earth, and we are looking for a location, it doesn't give you the exact location. It gives you like 40 meters minus or plus 40 meters.
That has nothing. You go ahead. I'm listening. Yes.
Is it like is that the buffer in relation to the GIS?
In fact, it relates. I'm very happy you're talking about this. You know, sometimes you have questions, but you need to get answers to them. Yes. When you have your GPS and it throws you off, isn't it? By a certain amount. And you are not sure. You are not sure exactly what the point. So it will be giving you points, you know, all over the place from where you are supposed to be. So you are supposed to be at the cross, where the cross is, but it's throwing it off. The concept looks like a buffer, but it's not a buffer. It's got nothing to do with buffer. The reason is that you could actually, it can also get closer. GPS coordinate could sometimes try and get a bit closer to where you are. What does it mean? It means you are having different circles. Are you okay? The GPS sometimes you're not sure whether, you are here, and sometimes you are kind of off. Okay, so you are right. It seems like, there's some kind of, error that is within, it's around you. Are you okay? The thing is going around you. It's trying to find you. Okay.
So sir, it will depend on the altitude or what?
The accuracy of a GPS is really dependent on the obstruction to the signal. So if you are within a building, then you may not get a lot of signals so that it can compute your location. But that is not what we are talking about. Don't forget that we are deviating from the topic. So buffering it's got nothing to do with your GPS error, which seem to be, so many possible points where you can, you are actually at one particular location, but the GPS giving you so many points that you are not sure which one it is. But that is not the topic. It won't come in exams. So what we are talking about now is not relevant to what we are talking about in this class. I won't even talk about accuracy of GPS in this class. I'll only describe how GPS works in the next, topic. But it's a good contribution. But I get and I understand why you are thinking the way you are thinking. Yes. All right. So buffering is like that. You can see from the board that we are having this one is a point buffer. This one is a point buffer. This is a linear buffer. And then that one is a polygon buffer. But you can do so many of them. You can do the first one, maybe 50 meters, do the second one, 55 meters. You can choose to do 50 millimeters away, 200 mils from the extreme. And it's up to you and what you want to do. As an engineer, the things you are taught are only a guide. You have to apply wisdom. Otherwise, you'll be blaming your lecturer for giving you the wrong stuff. Meanwhile, the lecturer himself knows that there's a lot you learn out in the field than what you teach in class. Okay, so here we are. I'm not missing something. Let me get it. Okay. Okay. So hey, look at what I've done. I've turned the whole thing upside down. Rotate, view. You have 10 minutes. Clockwise. Oh, we have 10 minutes. When it cuts, we move on. All right, so point buffer. You can also merge polygons. That's what we are seeing here. When you say buffer distance, I hope you all know what it is. That's what I showed you there. M is the buffer distance. It can be L. It's all up to you. Okay. So the buffer zone, remember that the end of a buffer operation is a polygon. Always put it in your mind. Whether you do point, line, or polygon buffer, you end up with a polygon. So that would be a second, you've created a new vector data set. Later, like I said, vector is points, lines, and polygons. And then raster is a picture. GIS. If you don't know this, you didn't learn GIS. So we will talk about vector and raster again. Is that okay? All right, I think all this has been talked about. The applications are many. Remember, we can do a wireless network coverage using buffer zones only. All right, guys. If you do GIS and you have to appreciate one thing: coordinate systems and coordinates and distances. Like these are things you should know, but you are taught in surveying as well. But you have to know it as a GIS person, because GIS, it brings together a couple of disciplines. So I won't waste time on this bit here. But let's appreciate that if you don't know what distance is, how to calculate distance between 2 points. I mean, I think it's basic in surveying, isn't it? Yeah. So Gotthold was drawing our attention to something. He said, where would I get my layers from? Very nice question to ask in the class. Where do I get, what I can't even touch them. You are saying layers. When we were talking about layers, and I told him that it's coming up. Are you okay? How we get those layers. And we get them by simply basic, fundamentally, collect the data. If you don't collect data, you won't have data. It's as simple as that. So we come to data sources for GIS. And let me tell you something. When you go to an examination, you read the words and understand it. When someone says data acquisition and someone says data source, really the person is talking about the same thing. Data source, data acquisition. Are you okay? Because you are acquiring something. Where are you going to get it from? From a source. So questions are, what are data? Someone starts talking about something, you wonder what it is. Okay. Please. There are about 3 or 4, data sources or data acquisition methods that we can apply in GIS or use in GIS. Those who are not listening to me, go to exam, I'll ask you data acquisition method, and you start saying that. Where is that in the notes? Okay. GIS data sources. Well, first one is surveying. Okay, so what do surveyors do? They simply measure coordinates. Are you okay? Anything the surveyor is doing is measuring distances and angles and computing coordinates. What is his objective? His objective then is to map, are you okay? Or to represent, what is on the ground. So if I'm a surveyor and I'm in this room and I want to represent this room as a polygon. So right from the time where I started measuring this room, the corners of the room, I have entered into GIS already because I'm creating a polygon in my mind. So in surveying, people don't pick 2 points to represent what? A polygon. You need at least 3. Then you can now join them up and get a 4th one. So that is what, surveyors do. They simply measure using equipment that allow them to obtain coordinates. Are you okay? And these coordinates can be 3-dimensional. In that case, you have X, Y, and then what? You said, are you okay? The Z is the height. Someone was talking about height. The Z is the height. Okay. All right. Now, photogrammetry is also another one. So for a lot of property, work, like I want to know who owns this property. Okay, things like that. Surveyors come in. You need a surveyor. If you don't, you can have, come buy a piece of land. It's basically a surveying thing. All right. So we have something like we call a cadastral plan and all these things. You just measure, obtain, get it. You don't need to do any serious. GIS is used anyway. It is used, but not heavily. The most important thing is really establishing the boundaries. Okay, for persons plots. They call it four corners, sometimes four corners. All right, so the instruments used have to be precise, because remember that when it comes to land, people get angry. Land is money, and so they will kill you for it. So the instruments used are very precise. Okay, it's supposed to be a very funny comment. Yeah, the equipment has to be precise. Otherwise, people will kill you for it. Because someone can cut pieces of land and then get a large one, isn't it? All right, encroachment and all those things happen. Photogrammetry is about taking pictures on the surface of the earth. You want to represent the earth. So in fact, what we are doing in GIS is that we are trying to model our world. I'll say it again. I've said it like 100 times in this class. We are trying to represent something that is real in the digital environment. Okay. So what photogrammetry is doing is that it's also trying to do what a surveyor is doing, but except that he is taking pictures of the ground and then he's going to work with it. And then let's see whether we can measure. That's all. Okay. At the end of the day, what you do is that you create a model, and the model can be 2D, 3D. Is that okay? And you create the model from the photographs. Is that okay? You don't say pictures per se, from the photographs, but obviously, yeah. Now you mount a camera under the platform that is going to be used to take the pictures. So it can be a drone. So you've heard of people using drone, yeah, for some projects. This is the idea behind it. It's called drone photogrammetry. That is in vogue today. It's a modern technology. Is that all right? So instead of having a biplane, what you are seeing on the screen is a biplane. You can actually have what? A drone which flies. I mean, what does a drone do? A drone is like a toy something, yeah? A replica of an aeroplane, a small miniature one in which you can't sit in a drone. Okay. So if someone tells you that I want to sit in your drone, then you should know there's a problem. You can't sit in it. There are different types of it. But then you need a platform. You house your camera normally, and then the camera takes pictures. The pictures, to create 3D models, they should be overlapping. So overlapping means that one should lie on top of the other. Okay. So to create overlapping photo, you take one photo like that, then you take another one on top of it, so that you have normally 60% overlap. Okay. Or per your specification, maybe 62 or whatever, per your calculation. And it's within the overlap region that the model is formed. Okay. All right. Now, at the end of the photogrammetric process, which the photogrammetrists can do, and they can use software to do with digital photogrammetry, they come out with 3D. Can you imagine 3D? Isn't that beautiful? Can you imagine generating a 3D for an area? You can do a whole lot of analysis, cut and fill, all sorts of things. All right. So one of the products from photogrammetry is what we call an ortho photograph. An ortho photograph, which is like a map. It's like you ask 20 surveyors to go and map, but meanwhile, this one, what you did was that you only sent a drone, it flew back and forth, and then now you have a map. And that map is actually not the line map, it's actually a photo map. Can you imagine that? So you can actually see everything, but you can measure from it. So it's a very nice product to have, for planning purposes and all that, because you see what is on the ground at the same time you can measure. Normally pictures, you can't measure from them, but photogrammetry makes it possible. Normally we take what we call vertical photographs. So yeah, I'm just giving you a summary of what it entails. We make use of ground controls. There's something that, you know, surveyors use to plant a pillar on the ground and call it a control. Horizontal and vertical controls are used. And then that is it. At the end of photogrammetry,